Section 3.3, function notation. Function notation is a vocabulary term. It's a method of rewriting or renaming a function. Now, what you're most used to is XY notation, where we have y equals mx plus b. Okay, this would be XY notation. XY notation, y equals mx plus b, and that makes sense. It's got an x and a y. Okay, function notation looks slightly different. It's this, and I'm going to explain what all that means and how you say it in just a second. So this is still mx plus b. Okay, this is function notation. Okay, the only difference between function notation and XY notation obviously is this. Okay, the y and then that f parenthesis x. Okay, so what we can assume then, if y and then that f and parenthesis x are both equal to mx plus b, what we can assume then is that y is equal to that f and the x. Okay, so then the question becomes, well, how do you say that? Okay, so how do you say this f parenthesis x? Okay, we can say you say it one of two ways. You could say it f of x, or you could say the value of function f at x. Okay, either one of those is correct. By far, and I would say 99.9% of times, it's this, f of x. Okay, so it would be, so this line right here, you would read it as f of x equals mx plus b. Okay, one thing I want to stress with function notation, f of x does not mean f times x. I'll erase that first x and put a dot. It does not mean f times x. Okay, write that off to the side. Not f times x. Okay, it is just f of x. We are not going to be doing any dividing when we have function notation. Okay, we might do some dividing if we have to evaluate something, but we're never going to just divide to get f by itself, because that's not what we're trying to do. We're not solving for f. F is just a name. F is not the only letter that could be used. Most often f is used, but definitely you could see something like g of x, you could see h of x, sometimes for some reason they'll put r of x, I've seen c of x. You know, there's different letters that can be used. All of them represent the same thing. They are all the same thing as y. Okay? The reason we use different letters is because we have different names. We want to use different names. Sometimes we have to graph two different things on the same plane, and if they're both equal to f of x, then we can kind of assume that they're equal to each other, and that's definitely not the case. So we just use different names. It'd be like I wouldn't name both of my kids Sam. I would name one Sam and the other one Steve, or something like that, where we want to give them different names because they are different functions. But in reality, they mean the same thing. They're both my kids, but they just have different names. Okay, so they're both going to be functions, but they might just have different names. Okay, so we can do several things with functions. We can evaluate the function f of x equals negative 4x plus 7, number 1 when x equals 2, and then number 2 when x equals negative 2. What evaluate the function means is really what this is trying to tell us is find y when x equals some number. And these are our two numbers here, 2 and negative 2 for this example. Okay, so how we're going to do this, wherever we see an x, there and there, we're going to replace it with these two x values. Obviously not the same time, one before one and then the other. So let's start with number 1. So whenever I see an x, I'm now going to make it 2. So it's going to be f of 2 equals negative 4 times 2, because there's an x, and then plus 7. We can do negative 4 times 2. This is still f of 2. Negative 4 times 2 is negative 8 plus 7, and then we can do negative 8 plus 7. F of 2 is equal to negative 1. This is your final answer. F of 2 equals negative 1. Okay, what this really tells me is that when x equals 2, the y value when x equals 2 is negative 1. So we could kind of think about the ordered pair 2, negative 1 being on the graph. We do not have to divide this by 2. I want to make that very clear. You do not have to do any dividing here. We do not need f by itself. This just says f of 2 equals negative 1, which tells me when x is 2, y is negative 1. Let's go ahead and try another one here. Number 2, when x equals negative 2. Okay, so we're going to do the same thing. So we're going to have f of negative 2 equals negative 4 times negative 2 plus 7. Go ahead and do negative 4 times negative 2. So f of negative 2 is equal to 8 plus 7. And then 8 plus 7, we can do that. F of negative 2 is equal to 15. And again, this is our final answer. We do not need to do any dividing. What this tells me is that the ordered pair negative 2, 15 would be on the graph of 4x, negative 4x plus 7. Let's try a couple more. So we got a new function, g of x is equal to 2x minus 7, and we're going to evaluate when x equals 4 and then when x equals negative 4. So let's start with 4. Again, wherever you see an x value or an x, we're going to replace it with 4. Okay, so g of 4, and again, this is an example where we use just a different letter. It's still the same concept, we're just giving it a different name. G of 4 is equal to 2 times my x value, which is 4 minus 7. We can do 2 times 4, so g of 4 is equal to 8 minus 7. 8 minus 7, g of 4 is equal to 1. So what that tells me then is that the point, or the ordered pair, 4, 1, would be on the graph of 2x minus 7. Let's try the second one here, when x equals negative 4. So wherever we see an x, again, we're going to replace it with negative 4 this time. So g of, there's x, so it's going to be negative 4, equals 2 times my x value, which is negative 4 minus 7. So we do 2 times negative 4, so g of negative 4 is equal to negative 8 minus 7. We can do negative 8 minus 7, g of negative 4 is equal to negative 15. This would be your answer if you were told to evaluate, which we are. What that means in terms of a graph, it means the ordered pair negative 4, negative 15 would be on the graph of our function 2x minus 7. Okay, let's move on to something a little more, I guess you'd call it abstract, maybe a little more general. We've got an example here. Let f of t, so now we're going to use a different variable. Let f of t be the outside temperature in degrees Fahrenheit t hours after 6 a.m. Explain the meaning of each statement. So number 1 says f of 0 is equal to 58. Okay, so what happened was we replaced t with 0, and it says t is the number of hours after 6 a.m. So if t is equal to 0, that time would be 6 a.m. Okay, because it's 0 hours after 6 a.m., which makes it 6 a.m. So at 6 a.m., it says it's equal to 58. And it says f of t is equal to the outside temperature in degrees Fahrenheit. Okay, so what this says is that at 6 a.m., the temperature is 58 degrees Fahrenheit. That's all that statement is saying. There's no function that we know, but we know what it's equal to, and we know the t value, so that we know the time. We can say that at 6 a.m. the temperature is 58 degrees. Number 2, f of 2 is equal to 64. So when t is equal to 2, remember t is the number of hours after 6 a.m., so 2 hours after 6 a.m. would be 8 a.m. So at 8 a.m., the temperature is, well, it's equal to 64 degrees Fahrenheit. That's all that statement is saying, that at 6 a.m. the temperature is 64 degrees Fahrenheit. Let's try another one. Number 3, f of 6 is equal to n. So when t is equal to 6 hours after 6 a.m., if you think about a clock, go 6 hours past 6 a.m., that would be noon, 12 p.m. So we could say at noon, the temperature, the temp is, now what's the temperature? Well, it just gives us an n, so we have to use n. We got to say it's n degrees Fahrenheit. We don't know what it is, so we have to leave it as n degrees. There's no other way around it. All right, so f of 3 is less than f of 9. So let's think about t. When t is 3, so that'd be 3 hours after 6 a.m., that would be 9 a.m. And then when t is equal to 9, if we think about 9 hours after 6 a.m., that would be 3 p.m. Okay, and what this says, this f of 3 is less than f of 9. What that says, we don't know what those temperatures are, but we do know that the temperature at 9 a.m. is less than at 3 p.m. We don't know what the temperatures are, but the statement here says that whatever temperature this is is less than whatever temperature this is. And we can put context to the F of 3 and F of 9. 3 being 9 a.m., 9 being 3 p.m., and then we can go from there. We can make our statement. Temperature at 9 a.m. is less than the temperature at 3 p.m. Okay, and then number 5 here, F of 4 equals F of 11. So if T equals 4, that's 4 hours after 6 a.m., that would be 10 a.m. And T equals 11, so that'd be 11 hours after 6 a.m., that would be 5 p.m. And the equation here says that they are equal. So what this statement is saying is that the temperatures, the temps at 10 a.m. and 5 p.m. are the same. They're equal. That's all that sentence is saying. We don't know what the temperatures were, but we know that they were equal. And that's all that equation is saying. That's all we can say about that equation, is that the temperatures at 10 a.m. and 5 p.m. are the same. Okay, so we've made statements, we've evaluated. Let's try kind of, I don't want to say reverse evaluating, but we're actually going to do some solving here. Okay, so for f of x equals 6x plus 9, find the value of x so that f of x is equal to 21. The key phrase here is find the value of x. So if they're telling us to find the value of x, they are not going to give us an x value. So this f of x equals 21 is not going to, or this 21 is not going in there for x. Okay? It says that f of x is equal to 21. So what we're going to do, we're going to take this 21 and we're going to replace this part, the entire part. So it's going to be 21 equals 6x plus 9. Okay, we're not going to replace x because the problem tells us to find the value of x. They're not going to tell us to find x and then give it to us. That doesn't make sense. Okay, this is now a two-step equation. We're looking for a value of x. Okay, it's a two-step equation, so we'll start by subtracting 9. So that gives us, see, 21 minus 9 is 12 equals 6x. Going to divide both sides by 6. 12 divided by 6 is 2, so our x value is 2. If you're not sure, go ahead and take this number, plug it right back in for x, and see if you get 21. And let's try that. 6 times 2 plus 9. 6 times 2 is 12 plus 9. That gives us 21. So we do have the right answer. So 2 is the value of x, so that f of x is equal to 21. Basically, it's giving us a y value. This is y, and we need to find x. Okay? Number 2. Whoops. Supposed to be 2 fingers to drag. For h of x equals 2/3 x minus 5. Find x so that h of x is equal to negative 7. Again, they're telling us to find x, so they're not going to give us x. This negative 7 is going to replace h of x. Okay, it says h of x is equal to negative 7. So we're going to go negative 7 equals 2/3 x minus 5. And then we're going to solve. Again, it's a two-step equation. First step is to add 5 to both sides, plus 5. Negative 7 plus 5 is negative 2. And that is equal to 2/3 x. Now, the question becomes, how do I get rid of the 2/3? Anytime you're multiplying x by a fraction, to get rid of the fraction, just multiply by its reciprocal. Multiply both sides by the reciprocal. And I'll make this negative 2 over 1, so then we can just multiply fractions straight across. What's going to happen, the 3/2 and the 2/3 will cancel each other out. I'm going to be left with x on the left-hand side. The right-hand side, the left-hand side, multiply straight across. 3 times negative 2 is negative 6. 2 times 1 is 2. So then negative 6 divided by 2 is a negative 3. So that would be your answer there for number 2. All right, the last thing in the section is graphing. To graph functions, it's just like section 2.2. We need to choose our x values, find our, in this case, f of x values, but remember f of x is equal to y. So I'll just write that off. So remember that f of x is equal to y. So our steps are going to be the same. Let's choose some x values, and then we'll go find some y's. 1, 2, 3, 4. I'd like you to come up with 5 x values. The x values I like to choose are negative 2, negative 1, 0, 1, and 2. That way you can see a good portion of the graph. And then to find the y values, remember it's plug and chug. We're going to take our x values, put them into our function, and figure out what we get for y's. Okay, so we'll start with negative 2. So y equals 2 times negative 2 plus 5. 2 times negative 2 is negative 4 plus 5, and that is equal to, not negative 1, positive 1. So that's going to be a 1. Do the same thing with the next one. So y equals 2 times negative 1 plus 5. 2 times negative 1 is negative 2, plus 5, that is 3. Do the same thing with 0. Y equals 2 times 0 plus 5. 2 times 0 is 0 plus 5, which is 5. Do the same thing with 1. Y equals 2 times 1 plus 5. 2 times 1 is 2 plus 5, that's 7. And then we'll just do it off here to the side. Y equals 2 times 2 plus 5. 2 times 2 is 4 plus 5. That would be 9. So we've got our x's and y's. Let's go ahead and graph them. Let me bring in some graph paper here. See if we can't make a fairly straight line. Not bad. We'll try again here. That one's a little better. We'll go ahead and make our x-axis here. Make sure you put arrows on it. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. 1, 2, 3, 4. And then we'll go ahead and plot these ordered pairs. So we had negative 2, negative 1. I'll do those in green. So negative 2, negative 1 is about right in here. Then we had negative 1, 3. So negative 1, 3 is here. And then it was 0, 5, which was, let's see, 1, 2, 3, 4, 5 is right here. Then we had 1, 7, which is here. And 2, 9, which is right there. Now the question becomes, do we need to draw the line? Are these the only x values we could possibly pick? I hope that you realize the answer there is no. We could choose different x values. We could choose a bunch of x values in between 0 and 1, or between negative 2 and negative 1, or between 1 and 2. Okay? There are so many x values that you could choose, you'd never be able to list them all out. So since we have a continuous domain, there's no way we could list out or choose all of the x values. We do need to draw a line between the points and draw arrows on them. Okay? So we can show that while we have 5 points, they are not the only 5 points that are solutions or 5 points that are on the graph. We do need the line to show that there are many more, both in between the points and outside of the points.